Good day, everyone. Welcome to another episode of Matric Corona Maths. Okay, so we've done some revision of grade 11 Trig, and now we're going on to the new work for Matric Trig. And what we start off is something called compound angles. Okay, where you've got a trig function and then a plus or minus inside of there. So the first thing that we're given is if you've got cos of a minus b, and this is going to be given to you on your information sheet, okay, cos a minus b is equal to cos a cos b plus sine a sine b. Okay? Again, that doesn't just come from two people sitting in a pub and deciding that's what they want to do. There is a proof for it on page 131 of Mind Born Maths. It's not examinable, so you don't have to learn it. But it is very interesting, and it's a very nice proof. So go have a look at it if you're keen. And that's just to show you that this doesn't come from people just making it up, that there is a reason for that. Right, before we go on, I just want a quick little reminder. Okay, I want you to go express as a function of theta, sine negative theta, cos negative theta, tan negative theta, and cos 90 minus theta, sine 90 minus theta. Right, give those a go. Okay, so with negative angles, okay, I treat them like, just as a way of remembering, remember it doesn't have to be. I always treat that angle as an acute angle, and that tells me that a negative angle will end up in quadrant 4. And in quadrant 4, the only thing that stays positive is cos. So sine of a negative angle is the same thing as negative sine of that angle. But cos of a negative angle is the same thing as cos of that angle, because the ratio of x over r will be the same. And tan of negative theta will be negative tan theta. And then 90 minus behaves like it's in quadrant 1. And in quadrant 1, all your trig functions are positive. Okay, but if I'm working, remember, if I'm bouncing off the y-axis, it's going to change the name of its co-function. And the co-function of sine is cos and vice versa. So cos of 90 minus theta will be in quadrant 1. So it's positive, but it changes name to sine. And sine 90 minus theta will be cos of theta. We're in quadrant 1. 90 should send off alarm bells. Name change. Okay, so that's just a little reminder of some reduction formula that we're going to be using in the next little task that we do. Good times. Right, continuing. So in this question over here, so we're going to work, you're given that cos a minus b, which we wrote down just now, is equal to cos a cos b plus sine a sine b. Right, using this fact, okay, so you can use the fact that cos a minus b is equal to that. First of all, I want you to show that cos a plus b, in other words, cos of an angle plus another angle, will be equal to cos a cos b minus sine a sine b, and that sine of an angle minus another angle will be sine a cos b minus cos a sine b. Okay, and these you do need to know. So, well, how do we go about this? So we've got cos a plus b. Okay, but we know what we can deal with is cos of an angle minus another angle. So I have to rewrite this a plus b as cos of an angle minus another angle, right? Because this formula allows me to deal with that scenario, cos of an angle minus another angle. Now your first angle is A, and your second angle is minus B. So A is your first angle, minus B is your second angle. And this formula over here that we're given says, well, if I've got that scenario, cos of an angle minus another angle, I can rewrite it as cos of the first angle times cos of the second angle, and the second angle is now negative b, okay, then plus, the plus sign, I'm just using my formula sheet, so plus sine of the first angle, which is A, times by sine of the second angle, which in this case is negative b. Okay, right, so now, you want brackets, you can have brackets, you don't have to. Well, cos of A is just cos of A. Okay, cos of negative b, well, we just discussed it just now. Cos of negative an angle, it's like I'm in quadrant 4, and cos stays positive. So cos of negative b is the same thing as cos of b. Okay? Sine of a is going to stay the same. But sine of negative b, if I'm in that quadrant, becomes negative sine b. Okay? And if I neaten that up, I'm left with cos a cos b minus sine a sine b, which is what I set out to prove. Okay? Cos of an angle plus another angle is cos of both angles minus sine of both angles. So I've just shown that proof. But it stems, you have to use that to prove it. Okay? And that's how we develop these formulas. Right, the next one I want you to try is show that sine a minus b is equal to sine a cos b minus cos a sine b. Your little hint, okay, is you're going to have to use reduction formula for 90 degrees. Okay? And in fact, okay, give it a go. The next thing we're asked to prove is using this again, so I've got to use that, go prove that sine of a minus b is sine a cos b minus cos a sine b. Well, the problem is, my rule deals with cos. Okay, the initial rule, sorry, deals with cos, and now I've got sine. Well, how can I change this sine into cos? Well, I can use the fact that sine of an angle is the same thing as cos of 90 minus angle. You're used to working in that direction. Cos of 90 minus the angle is the same thing as sine of an angle, but we can also work in that direction. So I've got sine of an angle. The angle in this case is a minus b. A minus b is just, could be one angle. If a was 50, b was 10, a minus b would be 40, right? So sine of an angle, okay, is equal to cos of 90 degrees minus that angle, and that angle is a minus b. Okay, so sine of an angle is cos of 90 minus that angle. If I now go distribute the negative, I get cos of 90 minus a plus b. Okay, so cos of 90 minus a plus b. Okay, so then, okay, so sine of a minus b is the same thing as cos of 90 minus a minus b, which is cos of 90 minus a plus b. And I could do this. Okay, I could say this becomes, I could put a bracket here. And so that's the same thing as cos of 90 minus a, okay, minus b. Okay, try from there. So now, carrying on. So now we've got the scenario we want, which is cos of an angle minus another angle. And if I've got cos of an angle minus another angle, okay, what's it equal to? Well, cos of that first angle times cos of the second angle plus sine of the first angle times sine of the second angle. So, using this formula over here, I'm going to say, right, cos of an angle minus another angle is cos of the first angle times cos of the second angle, which is negative b, okay, and then plus, got a plus sign in between, sine of the first angle, sine of the second angle, okay, right, so go apply your reduction formula to each bit. So cos of 90 minus a is sine a. Cos of 90 minus a becomes sine a. Cos of negative b is just cos b. Okay? And sine of 90 minus a is cos a. And sine of negative b is negative sine b. Okay? So if I simplify that one last line, I get sine a cos b minus cos a sine b, which is what I set out to prove. So I've shown thought we worried one stage here, I don't know why. That sine of A minus B is equal to sine A cos B minus cos A sine B. Admitted man, you doubted me for a minute?
I doubted you, but then I looked at that stunning outfit, and I think that is your base.
I know.
Suits you.
I know, I am the athletic type. Right, so we proved that. So just sine A, you change it into cos of 90 minus A, and then it's just that manipulation over there. I wouldn't really expect you to have been able to do that without first seeing it once, but now you should be able to manage it. Good times. Good times. Right, you've seen some of these proofs, so maybe you can try to give this one a go. Okay, I want you to show using this. So you're given that sine A minus B is sine A cos B minus cos A sine B. I want you to go show that sine A plus, sine of an angle plus an angle, is sine A cos B plus cos A sine B. Right, so try to do that one over there. Okay, but you've got to use that. To do that, you'd have to go back to cos. Okay, so we've got sine A plus B, but this rule enables us to deal with sine of an angle minus another angle. So how are you going to go rewrite it? You're going to rewrite it as sine A minus B, because I can deal with that scenario, sine of an angle minus another angle. So here's your first angle A, your second angle is minus B. So sine of an angle minus another angle is equal to sine of the first angle cos of the second angle. Okay, cos of the second angle is negative B. Did you get it? Right, minus cos of the first angle, which is A, sine of the second angle, which is negative B. Right, so go apply your negative reduction formula there, and you're going to end up with sine A, or cos of negative B is the same thing as cos B, okay, minus cos A times by, or sine of negative B becomes negative sine B, and then the negative and the negative make a positive. So I end up with sine A cos B plus cos A sine B. Right. Do you think I should give everyone a little treat to get into my Speedo to go the full swimming look?
Good heavens, is that a treat? That's more like a nightmare. Easy on.
Right,
easy
get that down, please. Good day. So we're going to be using these four rules now. We're going to apply those four rules over and over again now. Okay, so you've got cos A minus B. Okay, these are all on your information sheet. Okay, so get used to using your information sheet. You don't have to learn these off by heart, although it is good to recognize the patterns always. So cos of an A minus B is that, cos of A plus B is that, sine of A minus B, sine of A minus B, okay, is equal to that, and sine of A plus B is that. The way I remember it, okay, is there's always one thing messed up about people, or about equations. With cos, the messed up thing is that the sign in between is opposite, that's your messed up bit, otherwise the cos's are nicely together. With sine, the messed up thing is, well, the good thing is the sign stays the same. So that's a minus, and that's a plus, that's a plus. The messed up part is that sine and cos are all mushed together. Okay? So with cos, the cos's are together, okay, is the good part, the messed up part is the sign is opposite. With sine, the messed up part is the sine and cos are all mushed together. The good part is that the signs are the same. Right, so it's just a question of applying these rules, it's not difficult. Okay, so the first question says expand, your first example, cos x plus 50 degrees. So go pick the appropriate formula from there and go expand it. Okay, it's just one line. And then go to the next one, sine of 3 beta, okay, plus 40 degrees. Pick the appropriate rule, shove it into the formula, and you're done. Easy peasy lemon
Squeezy.
good. Right. So you go to the right appropriate formula, which is the plus one with cos. With cos, what happens? Well, the good thing about cos is that the coses are together. The bad thing is that the signs, the messed up thing is that signs are opposite. So it becomes cos x cos 50 minus sine x sine 50 degrees. And you're done. I've expanded that. There's nothing more I can do. And the next one, sine of 3 beta plus 40 degrees. There's the appropriate formula. So it's going to be sine of 3 beta. Okay, messed up thing with sine is that they're all mixed up. Cos 40, but it's the same sign, which is a plus. Then it swaps around. So it'll be cos 3 beta sine 40 degrees. I have expanded that. I am done. Okay, let's try the next one. It says, prove the following reduction formula using compound angle formula. So you never do this, okay, unless you're asked specifically to do it like this. Okay, so we know that cos 180 plus theta, remember 180 plus theta, just with the reduction formula, you're in that quadrant over there, you're in the third quadrant. There's no name change because it's 180, but cos is going to be negative. So you've known this with reduction formula, but now I want you to go try to prove it using the compound angle formulas. So you're going to have it using cos of an angle plus an angle. So you're going to be using this formula over here. Right, give that a go. So we've got cos 180 plus theta. So we've got cos of an angle plus another angle, and that'll be equal to cos of the angle times cos of the other angle, which is theta. Okay, the messed up thing is the sine, so it becomes minus sine of 180. Okay, times sine of theta. And cos of 180, I would have said without a calculator here, but cos of 180, if you think about it, at 180 the x and the r are the same, but the x is negative, so cos of 180 is negative 1, so I get negative 1 cos theta minus, well, sine of 180 is 0, sine theta, so I'm left with negative cos theta. Okay, so cos of 180 plus theta is negative cos theta. Right. Then give this one a go. Try to show that sine, using the compound angle formulas, show that sine of 90 minus theta is equal to cos theta. Okay, try that one. So, if I go over here, okay, sine of 90 degrees minus theta. Okay, well, what formula am I using? Sine of an angle minus an angle. That'll be equal to sine of the angle times cos of the other angle. Okay, with sine, the sign stays the same, so it's still going to be a minus. Okay, minus cos of 90. Okay, times sine of the other angle. So I've just applied that formula over there. And sine of 90 is equal to 1. So I get 1 times cos theta minus, and cos of 90 is 0 times sine theta. So I end up with cos theta, which is what we were hoping to prove. Lovely. All right, ladies and gentlemen, so the next one, examples we're going to do come from Mindborn Maths, grade 12, and exercise 4.2, C2, 4, and 6, and we're going to do D2, 4, and 6 as well. And the question says express as one term, and your first one is cos 2x, cos 3x, minus sin 2x, sin 3x. It's at two terms at the moment. Got to get it to one term. So, we're working backwards. Okay, we're working now from right to left in the given formula. So, it's just pattern recognition. So, I want cos, and then a minus sign. So, I'm going to be using that formula over there. Okay, cos of an angle, cos of another angle, minus sine of an angle, sine of another angle is equal to cos of A plus B. So, go try to do that quickly, just get it to one term. Well, if I'm using this formula, okay, I've got to add the angles together. So, it's going to be cos of 2x plus 3x, which is simply going to be equal to cos of 5x. So, your answer is cos 5x. Right, try number 4. Sine 10 degrees, cos 4 theta, plus cos 10 degrees sine 4 theta. Pick the appropriate formula on the right and convert it to the left. Okay, so we've got this pattern over here, okay, sine and cos mixed up, and with a plus sign in the middle. So in this case, I'm using number 4, that formula over there. And what does this become? It becomes sine of the one angle plus the other angle. So it's simply going to be sine of 10 degrees plus 4 theta. Okay, remember, okay, with cos, okay, the signs are opposite, but with sine, the signs are the same. Okay. Try question 6, we've done 2 and 4. So C number 6 says expresses one term, cos 2x sine 3x minus cos 3x sine 2x. So I want to look for an appropriate pattern, and I've got a minus sign and sine and cos mixed up. Okay, so I'm going to be using this logic over here. Okay, if you want, okay, perhaps just get into the habit of, don't have to, of rewriting it sine 3x cos 2x in exactly the same pattern as the formula sheet. So sine of an angle, cos of an angle, minus cos of that angle, sine of the other angle. Now it's in exactly the form you're familiar with. Okay, so in that scenario, okay, how do I rewrite this? Well, it's going to be sine of the angle that goes with sine in the beginning, which is 3x, okay, minus the angle that goes with cos in the first term, which is 2x, which is equal to sine of x. Okay. Okay, cos 2x minus sine 3x minus 2x. Yep, that's right. Okay, hope that makes sense. Okay, the next one says, it's from 4.2D number 2. It says, determine without a calculator, cos 70, cos 40, sine 70, sine 40. Well, the no calculator bit should say, ding, 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 special angles. And the way I remember special angles, or you can use right angle triangles. Your special angles are at 30, 45, and 60. Okay, and what I remember is that the x value here is root 4. They get smaller by 1 root, which is of course nonsense each time, but it's a way of remembering root 3, root 2, root 1, and 0. The y coordinates get bigger, 0, 1 root, root 2, root 3, and root 4, which is 2. Okay, so that's the diagram I use with special angles to help. Right, so first I'm going to have to get that, okay, to a single term. So you're just going to simply pick the appropriate formula. We're working from right to left, so give that a go. And that's the formula we're going to be using over there. Okay, so it's going to be cos of the one angle minus the other angle. So in this case, it's going to be equal to cos of 70 minus 40, which is cos of 30. Okay, and if I'm not going to cheat, then I use this diagram over here. What's the definition of cos? Shade your red cos x-ray. So cos is the x coordinate over the radius. Okay, the radius we're working with is 2. At 30 degrees, the x coordinate is root 3. So it's going to be x over r, which is root 3 over 2. Okay. Right. Then D4, I think it is. Yep, D4. It says evaluate without a calculator, cos 265, sine 355 minus sine 85, cos 175. So again, you can't go straight to the answer, you're going to have a bit of working out here. The first thing I would do in questions like this, because the problem is now the angles are all different. So I would get everything to acute angles, to angles less than 90 degrees by using reduction formula. So try and get everything to an acute angle by using reduction formula, and I would just as a habit avoid 90 degrees. Okay? Reduction with 90, so don't use 90 plus or minus. Use 180 plus or minus, or 360 plus or minus. Right, so try to get all of these for trig functions into acute angles. You don't have to change this one, that's fine, that's already an acute angle. but you do have to change these three. Okay. So all I'd say, right, 265 is where? Well, 265 is in quadrant 3, and in quadrant 3 I'm going to write it as 180 plus something. So I'm going to go cos 265 is cos of 180 plus 85. So that's cos 265. And then I'm going to times it by sine 355. Well, 355 is in quadrant 4, and it's going to be 360 minus. So it's going to be sine 360 minus 5 degrees. And I've got that minus sign. Minus sine 85 is already acute. And then cos 175, okay, is in quadrant 2. So I'm going to write it as cos 180 minus 5 degrees. Okay? Right. So now, if I go use reduction formula, cos of 180 plus an angle, I'm in quadrant 3. What happens to cos in quadrant 3? It becomes negative. Okay, there's no name change because it's 180, so it's going to be negative cos 85 degrees. Sine 360 minus 5. 360 minus, I'm in quadrant 4. What happens to sine in that quadrant? It becomes negative. So it's negative sine of 5 degrees. Then I've got that minus sign. Sine 85, I'm going to leave out that. Okay. Cos 180 minus 5, I'm in quadrant 2. What happens to cos in quadrant 2? It becomes negative, so it's going to be minus cos of 5. And if I check, well, the angles, got two pairs of angles, which is what I want. Let's just make it prettier. So to match up with the pattern, I want sine in front. A negative and a negative becomes a positive. So it's going to be sine of 5 degrees cos of 85 degrees. Here, a negative and a negative make a positive. And then it's going to be cos of 5 degrees sine of 85 degrees. Okay, and there I've got this pattern over here. Okay, not nothing absolute rubbish. I've got sine cos minus cos sine. So it's going to be in that situation, okay, plus. Okay, so it's going to be a plus sign in between. So I've got this pattern here. I'm going from there to there. Sine A cos B plus cos A sine B. Okay, sine 5 cos 85 plus cos 5 sine 85. And it's equal to sine of the two angles added together. So it's sine of 5 degrees plus 85, which is sine of 90 degrees. And at 90 degrees, what is sine the ratio of shade you're here? So sine is the y-coordinate over the radius, so it's 2 over 2, which is equal to 1. So your final answer, after all that work, is equal to 1. Okay, if you want to check, put that all into the calculator. Okay, the question said, no calculator.
Oh, isn't this enough?
Nearly there, last one.
Oh my goodness, these lessons are long.
Oh, I'm sorry. Okay, we'll be starting this session with a little rant from the musician about mathematics.
All I'm saying is that I don't understand how the girls stay awake, because this is the most boring thing I have ever heard.
And all I'd like to say is during this time of crisis, coronavirus, are we looking at violin music sheets, or are we looking at exponential curves and trying to flatten the curve?
And how
I don't hear anybody saying try flatten the whatever.
I'm sure these girls are singing more than doing maths.
They're loving this. Right. Okay. Again, the next question is, okay, go evaluate it without a calculator, which means I've got to get to special angles. But, well, I can't use the compound angle straight away because these are all a mess. So my suggestion is anything that is not an acute angle, you get it to acute little angle. Oh, okay, so get those two things to acute angles. Okay. So cos 50 is going to stay the same, avoid 90. So I get cos 50. Right, sine 260. Okay, I'm sitting in quadrant 3. Okay, 260, so I'm going to write it as 180 plus something. So sine 180 plus 80. Okay, cos 10 is already acute, so I'm going to leave it as cos 10. And sine 140, I'm in quadrant 2, so I'm going to write it as sine 180. minus 40. Okay, so now I've got cos 50. 180, sine of 180 plus, I'm in quadrant 3, sine becomes negative, so it becomes negative sine 80. Okay, plus cos 10. Sine 180 minus 40, I'm in quadrant 2, sine stays positive, so it's just sine 40. Right, and now, if we neaten it up, I've got this. I've got cos 50, sorry, negative cos 50, sine 80, plus cos 10, sine 40. And now you're like, oh my goodness gracious. The problem is my angles are different. But what can help us here? Well, remember with complementary angles, okay, cos of an angle is the same thing as sine of 90 minus theta and vice versa. So in other words, cos of 20 degrees would be equal to sine of 90 minus 20, which is sine 70. You don't have to show any of that working for that. If cos of 20, then add up to 90 will be equal to sine 70. So cos of 5 degrees would be sine of 85. As long as they're complementary. The co-functions means complementary functions. So sine of 30 degrees would be the same thing as cos of, they've got to add up to 90, cos of 60. Okay, so use that. So here, how does that help us? Well, 10 and 80 are complementary. So you can decide. And there are different ways. You can either get them both to 80 or you can get them both to 10. Okay, let's get them, I don't know, let's get them both to 80. So I'm going to leave this for now, we'll deal with that later. Sine of 80 is the same thing as, we're going to leave it as sine 80. You could have got that to cos 10. Okay, you'll end up with the same final answer. But cos of 10 is the same thing as sine of 80. Now the angles are the same. And likewise, 40 and 50 are complementary angles. So you can pick, do you want to get them to 50 or do you want to get them to 40? Doesn't matter. As I say, you'll get the same answer. Let's stick with 50. So it's going to be negative. I'm going to keep that negative there. Cos 50. And then sine 40 is the same thing as cos of 50. So now, okay, I'm going to end up with, well, it's up to you. We can rewrite it, swap them around. Sine 80 cos 50. Hang on. Press pause. Something seems to have gone wrong. Right, I did a crucial thing and I doubted myself. Okay. And there is no need to doubt yourself because sine 80 cos 50 minus sine 80 cos 50 is simply going to be equal to 0. And we are done.
Goodbye.
The family are getting grumpy because they want to eat lunch. So I want you to do now Mind Maths grade 12, read examples on page 132 and 133. Then I want you to do exercise 4.2, page 134, all of A and B. And then C and D, just the even numbers. We've done, no, I'm lying, just the odd numbers. We did the even numbers as examples.
Thanks.
Right, have fun, stay strong,
Bye.
and may the force be with you. Everyone say goodbye.
Cheerio, bugger off.
I apologize for that absolute rudeness. Musicians are very, very temperamental.